Now we will study in this chapter the foundation of business intelligence, and we will focus on databases and information management. At the end of this lecture, I hope you will be able to answer the following questions. The first question is, what are the problems of the managing data resources in a traditional file environment, and how are they solved by introduction of database management systems? The next question is, what are the major capabilities of database management system, and why is a relational database management system so powerful? The following question is, what are some important principles of database design? The fourth question is to be clarified, what are the principal tools and technologies for accessing information from databases to improve business performance and decision making? Last but not least is the question, why are information policy, data administration, and data quality assurance essential for managing the firm's data resources? To answer those questions, we have to start first to understand the origin idea and concepts of how the first generation of information systems worked and how it dealt with its own data resources. We have to imagine the following situation. A company, XY for example, in the past owned normally several organization units, and each operated a specific function area. So we consider that every function area is a department like finance, sale and distribution, purchasing, warehousing, production planning, etc., etc. Departments have used information systems separately, and each department has consequently different information systems. These information systems store the data in so-called traditional file environments. Before we continue, we should first explain the main elements and concepts of a traditional file environment. The first term is database. Database can be seen as a summation of all files maintained by an information system to support a department or function area. While file contains data as a set of real-world objects that have the same description, always the same description. The file customer has the same description for every customer stored in the file, like customer ID, name, surname, address, and phone. An object stored in the file, it can be also called record. So, one record consists of several fields that representing the value of its attributes. For example, the attribute name has the field value Muhammad. The attribute customer ID has the field value 001, and so on. So when we speak or talk about description of a field, then we use the term attribute. On other side, when we talk about the field value, the value of the field, so we use just the term field. So when we speak about description level, we speak about attributes and entities. When we speak about values, we speak about records and fields. So field can be group of characters as word or numbers. In this figure, we see an example for a database. This database contains a group of files: course file, financial file, and personal file. And every file hosted a set of records described by attributes. Attributes like student's ID, course, date, and grade. A record itself contains just fields with values. At the low level of computer architecture, this value could be 0 or 1. So a byte can contain 8-bit or contain 8-bit, and bit could have just 0 or 1 as a value. Data redundancy is defined as the duplicate of data in multiple data files so that the same data are stored in more than one place or location. In other words, it is repeating storing of the same data in different information systems of different departments of a company. This leads normally to growth of unnecessary storage space, and very important, it could lead to data inconsistencies. Data inconsistencies, I think it is the most critical disadvantage. Data inconsistency, where the same attribute may have different value. For instance, when the address of a customer is changed in financial department and not updated in the logistic department, it may very well be that the deliveries could send to the wrong address. In a traditional file system, program application and data are almost melded together and close interlinked. In classic file environment, every traditional computer program has to describe location and nature of the data with which it works. Therefore, any changing in data file structure requires changing in the program code to consider this change. If, for example, the field postcode is changed from 5 digits to 9, an external program may access just the first 5 digits because the program of an external information system is not updated to match the changing done in the postcode field. Such changing in program is not simple task. It required expensive programming skill and extensive and huge effort for maintaining the program. Lack of flexibility. It is a very important disadvantage of file system. A traditional file system can deliver scheduled reports after extensive programming efforts, but it cannot deliver ad hoc reports or respond to unexpected information requirements in timely fashion. Several programmers might have to work for weeks to put together the required data items in a new file. There is no standard mechanism and tools to handle ad hoc queries. An ad hoc query is created in order to get information immediately when need arises without the need of programming activity. So the next disadvantage is data security. Because there is a little control and management data access and distribution of information, it may be out of control. Management may have no way of knowing who is accessing or even making changes to the organization's data. Here we need also standardized mechanisms to control and manage data security. So we are coming now to the last disadvantage of the file environment of traditional information systems. That is lack of data sharing and availability. Because of island landscape, I call it island landscape because information systems are separated over different departments within an organization. They are not linked to each other, and therefore we call it islands landscape, island solution landscape. Therefore, it is virtually impossible for information to be shared or accessed in timely manner. For the user, for example, they can find different values of the same information in two different systems. They may not want to use it because they cannot trust the accuracy of their data. That's the problem. As we see here, it is example of traditional file processing. So each department or functional area of an organization has its own application program. And these application programs maintaining its own data files. Data files, they could repeat it from logical point of view, for example, customer master data in different departments, and that can lead to redundancy of data and worse, to inconsistencies. Now we will explain the database approach to data management using database management system. A database management system is defined as software that allows an organization to centralize the data, manage them, and control accesses to the stored data by application programs. The database management system functions here as interface between application programs and the physical data files. For example, in the case of traditional data files, the programmer would have to specify the size and format of each data element used in the program, and then tell the computer where they were located. By separating the logical and physical views of the data, the database management system here can relieve the programmer or the end user from the task of understanding where and how the data are actually stored. The logical view presents data as they would be perceived by the end user, while physical view shows how data are physically organized and stored and structured on the physical storage media like hard disk, for example. In addition, database management system solve the problem of the file environment, like redundancy, inconsistencies, and uncoupled program and data, and then we will get more flexibility to manage queries. and in addition enables organization centrally to manage data security. So in this figure, we can see an example of database management system with centralized database, and the database management system function as a hub or interface between the programs and the data itself. The programs can deliver information, retrieve information from the database depending on the role assigned to the user. So the user here can see just the information that allowed by his profile. And this all user profile are managed by database management system to ensure securities and control accesses. So tables stores data within rows. Row, for example, table student. Table student store the value Ahmad Hani for attribute name and New Cairo as a value for attribute address and BINF201 for attribute course, and so on. These values together are representing a line or record within a table. We called also row. A field represents attribute for entity within a row. A key field is used normally to identify a record of a table. There are two kinds of key fields. The first one, and the very important one, is a primary key. It's a field in table used for key field to identify a record. For example, customer ID should not repeat it for more than one customer. It must record once within a table. So we can identify specific and just one customer. So we will explain now foreign key concept. A foreign key defines a column that enforces a relationship between two tables. It is the responsibility of the database management system to enforce this relationship to ensure data integrity. In another word, a foreign key functions as a pointer to another table to get, for example, more information about it. And this information is stored in another table where this foreign key is defined as a primary key. So to illustrate this concept, we make another example. A student table had the field with the attribute course ID, and course ID is defined as a foreign key. over this course ID, we can link to the original table where this course ID is defined as a primary key in this table course. So we can link from our table students where foreign key course ID to get more information about the course itself. So we can jump to the course table and get more information about this course, like course name, instructor, credit points, and so on. So in this slide, we can see an example for an entity for a supplier. A supplier has attributes like supplier number, supplier name, supplier street, city, and a supplier SIP. In this case, we see just 4 suppliers, and each record of this table represents a supplier, specific supplier with specific value. So we have here the field supplier number is defined as a key field, and namely primary key, to identify every supplier. So each supplier has an ID, supplier number, and it's not allowed to repeat the same value. For a foreign key, we will see here another example for entity part. It is the same principle. We have attributes as a column header and the values of records and fields. The primary key defined here is the part number, where supplier number is defined as a foreign key. So a part can just supplied by one supplier, but supplier can deliver more than one part to an organization. For example, when we want to see or to catch more information about the supplier, because just supplier number don't say so much about the supplier. So the supplier as a foreign key function here as a pointer to the other table of the supplier. If we want to see more information about the supplier 8259, so over the linkage of the foreign key, we can jump to the supplier entities and get more information about the supplier. And we call this technique referential integrity, to link between the database files or tables. So there are standardized operations to access on the data of our database management systems. So database management system provide tools to access on the data. And the first operation that we can use is select. Select creates subset of data of all records that meet stated criteria. Stated criteria, which criteria you require for accessing the data. For example, select name, surname from customer here as entities, where city is Cairo. So you will give you all this record with your stated criteria. All the customer, they have their address in Cairo with name and surname. Join to combines relational tables to provide user with more information than available in individual tables. So here we will use the concept of foreign key to link one table to another table. For example, to see all information we need that's depending on the required stated criteria for join operation, like all the attributes of the table parts and suppliers. So project creates subset of columns. Not all attributes of record will appear here, but just a subset of the columns of the attributes. That depends on the user. So create subset of columns in table, creating tables with only the information specified. So we can see here the three operations. Selection, we use selection just for one table to pick required records, and join operation to get information about stored into table used foreign keys. A project selected columns project operation. In this case, in the bottom of the slide, restricted on just 4 criteria, 4 attributes from 2 different tables, namely part and supplier. There are also another types of database management system. For example, object-oriented database management system. Normally, they imitate real world objects like a human being. Everyone has its own attributes, descriptions, and also behavior. This means methods. And these procedures are also stored in the database. And that is more fitted for multimedia objects. But I think it is not important for us at first. You have to focus on relational database management system. That is the important data sources in an organization nowadays. And there are also a database in the cloud. They are a little bit different from a traditional relational database, but it is not our focus for this semester at least. But you have to know it first. So here we will learn a little bit about SQL, Structured Query Language. This structured query language is very important to conduct operations that we discussed before, like selection, join, and projection. SQL can be divided into 2 parts. Data manipulation language and data definition language. So data definition capability to specify a structure of database content used to create table and define characteristics of fields. Here, you will create a new table, a new entities with attributes, with data type, and so on, to define tables and define a primary key and foreign key. In order to do this, we have to use data definition language of SQL. We have also data dictionaries, so it's very important for definitions of data elements and their characteristics. Data manipulation language, so we can use it to operate our operation, like selection, projection, or join operation, to retrieve data from database, to extract data what we need. So we use a structured query language in this case. It's a standardized language, and this is very important to produce ad hoc query, what we discussed before. Microsoft Access uses tool for generation SQL. That is an example, but not just Microsoft Access. All database management systems had their own SQL. We call them native SQLs. Here an example of Access Microsoft. We will see here you can define your own table and attributes, the field names, data type, and you can describe them. That's very important for administrator to follow the meaning of the fields. An example for SQL query. So a selection operation, select part, that's the name of the entity, name of the table, dot part _number, this means attribute or the field part number, comma, this means and part dot part name, the part name attribute of the part entities, and so on. From, after from is coming the name of the entity of the table. So the select keyword followed by column or fields of tables. Whereas from, after from keyword coming normally the name of the tables, and where as a keyword is the conditioning, the criteria. That's a part.supplier number equal supplier.supplier number. This means the supplier number at the field of the part entities must have the same value like a supplier number field of the table supplier. And part number equal 137 or part number equal 150. So that is our condition. Based on this condition, you get your information from two tables. So designing database runs over two views: the conceptual or logical design and physical design. The logical design is abstracted view on the data from business perspective that everyone can understand, where physical design to design the data in physical media for a specific database management system, for example, for Oracle or for DB2, so you can design your data in it. So it is a difference between conceptual logical design independently from database management system you use and the physical view of it, and the physical design is specific for specific database management system product for a specific hardware environment. So normalization is very important when you design a logical design of a database. In this case, you may separate many tables for each other to streamlining the complexity of the database, your database, and to avoid redundancies. For example, we can put part table with supplier table just in one table, all the information of both, but that can lead to repeat many information if a supplier of the part is a peer, so we have to repeat all the information of this supplier once and once again. And just to use the foreign key, we will reduce amount of data that can be stored in this table. So we can see a normalized relation contains repeating group. So we have order number, order date, part number, part name, and so on. We have many information about suppliers, about part, about order. We can put all this data in just one table, but there are many information repeated here. So the best way to normalize this table, this means to separate them in different independent tables, a table for supplier, table for part, and table for order, and we can connect them over primary and foreign keys. So we can see here in this slides, it's already splitted in part, line item, supplier, and order. Entity relationship diagram is the most known diagram to model a database from logical point of view, or we call it conceptual model or logical model, used by database designer to document the data model. When you want to create a database, first of all, you have to describe it in paper. You have to draw it with ERD diagram, for example, to illustrate relationships between entities. Another aspect of database, so-called distributing database. There are two types of distributing database. The first one, partitioned. Partitioned, that means I will separate parts, distributing parts in different locations. And that's why it's called or named distributed database. or I replicate the database in other place. And this application sometimes makes sense when a failure in original copy of the database or the system is down, whatever. So I can use the replicated database as a standby database. So we see here an entity relationship diagram using crowfoot notation. So I will start from the left side. We have the entity supplier. Entity supplier, a supplier, can supply one or more parts to an enterprise. So we have here the relationship one to many. So one supplier can deliver many parts to the organization. And one part must be delivered by one supplier in this notation. Okay? So an order at the right side of the figure, an order can contain one or more line items. What is line item? Line item represent a line with an order. So an order has several lines, like for example the first line about the item description, item name, price of the item, amount of the items, and the total price. And the second line, another item with another price with another name. So every line item must belong to one order. And also, apart this item appeared in a line must belong to one part. So a line item belongs to one part, but one part can appear in several line items of several order. I know that's a little bit difficult. So why we put the line item here between order and part? That's a good question. Actually, the relationship between part and order is many to many. So one order can have one or more part. And one part can be ordered in one or more orders. So the relationship here is many to many, and many to many is not allowed in ER modeling, entity relationship modeling. So we have to convert them and put a new entity between the both. And that makes sense because every line item has information that could not be stored either in order or in part, like the amount of the item. The amount of the ordered item, I cannot put this information either in order file or in part file. So I need a new entity, and this case is a line time, a line item. So moving now to the next topic, and how to use databases to improve business performance and decision making. So at the first part, we analyze and discuss the concept of database, and primarily to use it for conducting business process, to automate tasks, to change tasks, to create a new order, to create a new material and deliveries, and so on. but we can use this data also to support decision making. And supporting decision making, we can call it in general business intelligence. It's a term as an umbrella for all techniques that lead to supporting decision making in an organization. So normally, very large databases and systems require special capabilities and tools to support decision making. In order to analyze large quantities of data, to access data from multiple systems. So normally we don't have just operational data that in our core and primary data resources, but also we can use another sources of data from external data, from our supplier, customer, competitors, whatever. And also, how can we manage this? There are three different main key techniques: data warehousing, data mining, tools accessing internal databases through the web. We will go through all these terms. The first concept we have to learn here is the data warehouse. Data warehouse, it's nothing else than a database, but a special one. That's a database specialized just for retrieving information and extracting data. It's not allowed to update data, to change the data already stored, because data warehouse mainly stores historical data. And when we want to change this data, we make actually manipulation. We changed what already done. So the sale volumes of the day XY, we cannot change it because it's fact, it's already done. So historical data cannot be changed. So, and it also consolidates and standardizes information for use across enterprise. Standardize, that means give them structures, standard structure to be retrieved and analyzed. We can analyze the data by using a special search engine. We call it OLAP engine. So data will be collected from operational system, TPS, transactional processing systems, say every weekend, for example, and we export the data to the data warehouse and store the data over there, integrate them in so-called data marts. Data marts, it's a subset of data warehouse representing, for example, a function area like sales or human resources or logistics and so on, and summarize the data in portion and used for a specific population of user for analyzer. Okay, typically focuses on single subject or line of business for, as I said before, for sale and distribution, for marketing, for deliveries, and so on. So it's subjective. We handle a subject here according to the function area needed to be analyzed. we can see here there are many of the left side, many resources, operational data, customer data, manufacturing data, historical data, they all are historical data, and also external data. We export this data, extracting them, transform them to be aligned. For example, if we have the same customers, but has different descriptions, we have to align, consolidate this description. We transform this, but we don't changing any data. It's not allowed to change any data. And after ETL process, extracting, transformation, and then loading the data in data warehouse. After loading the data in the data warehouse in so-called data mart, so we can access the data and use OLAP functionality or data mining or a simple query. Business intelligence again. As I said before, it's the umbrella, the term that cover all techniques that lead to improving decision-making in an organizations. So the formal definition is tools for consolidating, analyzing, and providing access to vast amount of data to help user make better business decision. Principal tool includes software for database query reporting, like SQL, for example, online analytical processing engine, we call it OLAP, short OLAP, and data mining techniques. OLAP supports multidimensional data analysis. So this mart stored in multidimensional model. It's like a cube. So there are dimension for date for the time, dimension for customer and customer group, dimension for product and product group, and we call every dimension has its own aggregation level. So we aggregate actually facts for a different dimension level. For example, facts, it's numbers like sales or cost. So when we went to calculate the sales of the last 3 months for a specific branch in a specific area, so we'll speak a different dimension criteria to calculate facts. So that's why it calls multidimensional model, because I have different criteria depending on dimensions to calculate facts. So here as an example, how many washers are sold in the East in June compared with other regions. So this is a traditional query for multidimensional model. OLAP engine enables to answer these questions immediately. Immediately, that means as ad hoc query. We can see here our a cube with different dimension, product dimension, region dimension, and projected actual dimension. We will explain here the main concepts of data mining techniques. Data mining used normally for to discover hidden pattern. Hidden pattern, that is pattern, it's not obvious to be retrieved or perceived by a human. So we let data mining algorithm runs over a huge amount of data to discover a hidden valuable information and relationship, and also to forecasting purposes. For example, finding patterns in customer data for one-to-one marketing campaigns. We don't know really which customer are fitted for our campaign. So we will discover them by using data mining techniques and clustering them by using, for example, clustering methods for data mining, or to identify profitable customers, the customer as potential to be a valuable buyer. There are many types of data mining techniques. The most important techniques are the following: associations, rules, sequence analysis, classifications, clustering, and forecasting. Forecasting, actually, you can use clustering and classification for prediction purposes. Predictive analysis uses data mining techniques, historical data, and assumption about future conditions to predict outcomes of events. Example for that: probability a customer will respond to an offer. To calculate, to determine the probability of a customer response. We can use predictive analysis to determine, for example, the next production program, to calculate the sales of the last years and behavior of the market, and another market characteristics like unemployment, power purchases factors, and so on. Text mining, in turn, we analyze text unstructured data to retrieve information and to understand text by using machines. Web mining. Web mining is used actually in the web sector to understand the behavior of the web user and to find out some problem according to the content by using content mining, and also to investigate web structure. We call it web structure mining. And finally, web usage mining by using, for example, sequence analysis to track the click stream of the user and to see if the web pages link it properly to each other and such stuff. Database in the web. Many companies use the web to make some internal database available to customer or partners. So we are using web application to access on the web. typically configuration includes web server to manage the websites. We have also application server where the application are hosted, and database server where the database is hosted and managed by database management systems. Advantage of using the web of database accesses. First, ease of use of browser software. Everyone has its own browser. We don't need a client software to be installed to get connection to our application, which may stored in remotely in other place. Web interface requires few or no changes to database. And inexpensive to add web interface to any system. Here it is a classical landscape of different web server. The most important one for us here is the web server. So you will see here a client with web browser can connect the web server over the internet. The web server is connecting afterward application server. The application server connect the database server, and the database server access on the data. So it is a classical landscape of servers. Now we come to the big data concept. Surely, for sure, you have heard about big data. What is exactly big data? Big data, as the name said, it's a huge amount of data stored, and how can we use it? So, data sets that are large enough to go beyond the capability of traditional database management system to control and maintain. What does it mean? A huge amount of data cannot easily handled by database management system, especially when we retrieve a huge amount of data. It could take hours or even days to determine records and display them. We have different kind of data varieties and velocities. It's very important. We need the data ad hoc immediately. We cannot wait too long time, especially when we want the data to make real-time decision making. What is urgent? When is it? It is urgent. In this case, we use a new concept, a new system handle such data, especially for also data streams. Data streaming cannot be handled either by a normal traditional database management systems or even by a data warehouse. Big data can handle this. Big data has its own analytics, using data mining thereby to generate insight from big data. This is used by both commercial enterprises and government agencies. So, establishing an information policies. So So we discussed different kinds of databases. First of all, traditional file environment, database management systems, and modeling of database management of databases in general. And then we learned a little bit about business intelligence, data warehousing, data mining, big data. And we need a policy to control and manage all these kinds of data. By using firms' rules, procedure, rule for sharing, managing, and standardizing data. So we can summarizing these rules as follow. Data administration, that means firm function responsible for specific policies and procedure to manage data. So that have to be set by the management, this rule, to identify which persons they are allowed to get which information, or to insert information or update information. Data governance, policies and processes for managing availability, usability, integrity, and security of enterprise data. So, it's very important to consider related government regulations because a big industry, they are in stock market, for example, and they are responsible to manage the data to ensure the availability and security of the data, and to issue reports for government or for stockholders to ensure the policies. And there are many standards like SOX or COBIT in Europe and so on. That is a frameworks that organization has to follow. Database administration. It's very important aspect how to administrate database, how to handle day-to-day tasks and services. If a hard disk is down, or a user needs a printer, online printer, whatever, these tasks and activity must be standardized and organized through IT department. Database administration contains the following activities like defining, organizing, implementing, maintaining database performed by database design and management group.